Yes, good evening everyone. Please turn on your video before we start the class. Fine. So now we will be going ahead with the topic. So in the last class we have done up to this question number 5 of this exercise. Okay. This up to question number 5 we have completed. Now we'll be going ahead with it. Okay. Now the next is question number 6, that is diagonals of AC of a parallelogram. Okay. So if I want to solve this, yeah, fine. So what is given over here? Diagonal AC of a parallelogram ABCD. This parallelogram is given and the diagonal AC of a parallelogram bisects angle A. That means if this is your angle A, it bisects this. That means this angle is equal to this angle. Fine, both the angles are equal. Now you have to show that it bisects angle C also. Means if it is given that it bisects angle A, you have to show that it bisects angle C also. That means this angle is also equal to this angle. So how we will show that? That's what the working we have to do. Now, see what is given. ABCD is a parallelogram. Yeah. Since quadrilateral ABCD is a parallelogram, so what we know, if it is a parallelogram, we know that AD is parallel to BC, and yeah, we know that AD is parallel to BC. This is sufficient. Yeah, if AD is parallel to BC, can I say this angle is equal to this angle by alternate angles property? Yeah, that is angle
Yes,
DAC will be equal to angle ACB. Which type, by what property? Alternate angles. Yeah. Also,
yes, sir.
yeah, yeah. So this we got that angle DAC is equals to angle ACB. Now, one more thing. Now over here, we already knew that this angle is equal to this, and these two angles are also equal now. Yeah, we already knew that angle DAC is equal to angle CAB. Why? Because it is given. Yeah. So if this is your 1 and this is your 2, from 1 and 2, can I say angle ACB is equal to angle CAB? Yeah. Therefore,
Yes, sir.
angle ACB is equal to angle CAB. That means what? That this angle ACB is equals to CAB. That means this angle is equals to this angle. Yeah. Now if this angle is equal to this
Yes, sir.
angle, then what will happen? I'll take the diagram over here. Yeah. Now if this angle is equals to this angle, so in triangle ABC, in triangle ABC, in triangle ABC, this angle is equal to this angle. That is angle ACB is equals to angle CAB. Therefore, AB is equals to BC. Yes or no? Sides opposite to equal angles are equal. Yeah,
Yes,
yeah. What we can see the reason, because the triangle ABC is an isosceles triangle, no? That's why. What will be the reason? Sides opposite to equal angles are equal. We can say this. Yeah. Now if they are equal, now this is equal to this is equal to this. Fine. Also, in again, DC is parallel to AB. That is we already know, since ABCD is a parallelogram. Yes or no? Since ABCD is a parallelogram, so can I say DC is parallel to AB?
yes,
Yeah. So if DC is parallel to AB, then angle DCA will be equal to angle CAB. Yes or no? What will be the property? Everyone has to keep their video on.
alternate angle.
Fine. So angle DCA is equal to angle CAB. So that gives you these two angles are also equal. Yeah, why? The reason is alternate angles. Yeah. So this angle is also equal to this angle. Fine. Now what do we get from all of this? These two angles are also equal. Therefore, what I can say, angle DCA is equal to angle ACB. Yes or no? We got that all the angles are equal. So therefore, can I say AC bisects angle C? Can I say that?
Yes, sir.
Yeah,
Yes, sir.
yeah. Therefore, AC bisects angle C. Clear? You can also say angle DCB. Clear? That's what the
Sir,
proof required. Yeah.
sir, in that last step, DCA equal to CAB, that,
Hmm.
sorry,
D
ACB, that how
this
it
one.
will,
See,
yeah,
see, I have marked them, no? See, this all angles are equal only, no? The marked things. See, before this, all these three angles were equal.
yes,
Yeah. After comparing it with this, we got that this angle is equal to this angle. So can I say this angle is
yes,
equal to this angle? Because all of them are already equal, no?
okay,
Yeah. That's why I can say angle DCA is also equals to ACB. Means from all these equations which we have solved, from 1, 2, 3, 4, you can say, from all of them. You can say that this angle is equal to this angle. Yeah. That's why AC bisects angle DCB. Clear? Any doubt over here? You can ask your doubt. Yeah. Fine. The first thing is proved. After that, you have to prove that ABCD is a rhombus. That can also be proved. We already knew that this angle is equal to this angle. Yeah. Over here again, see, in triangle ABC, angle CAB is equals to angle ACB. Therefore, AB is equals to BC. Yes or no? So if the adjacent sides are equal of a parallelogram, then it will be what?
sir, it means all the sides are equal.
Yeah, all the sides are equal. Then that means it's a rhombus. Therefore, AB equals BC equals CD equals AD, and therefore what we can say ABCD is a quadrilateral. ABCD is a rhombus. Is that clear? If you have any
Yes,
doubt,
sir, it can be square also.
no, it cannot be square. It can be square only if one of the angle is 90 degree. But we do not know it, no, what will be the angle. If one of the angle is 90 degree, then what we can say, it is a square. For a parallelogram, if one of the angle is 90 degree, then what can we say about that quadrilateral?
Rectangle.
Yeah, then it will be a rectangle. Fine. Now the next. So this has been done. Next, ABCD is a rhombus. Show that AC bisects angle A. This is almost the similar sum. You can means the same kind of sum. You can solve this question in your homework. Yeah. The next, ABCD is a rectangle in which diagonal show that ABCD is a square and diagonal BC is almost the same only, but still I will solve it. Same type of question. What they said, ABCD is a rectangle in which AC bisects. Fine. Let us first draw the rectangle. Yeah, this is what your rectangle. ABCD is a rectangle in which diagonal AC bisects angle A. Okay. Diagonal AC bisects angle A. That means this angle is equals to this angle. Got it? This angle is equal to this
Yes,
angle as well as angle C. That means this angle is equals to this angle. That means if I say this angle is equals to this angle as well as angle C. Show that ABCD is a square. It was given that quadrilateral ABCD is a rectangle. Yeah. So for a rectangle, all the angles are 90 degree. We know that all the corner angles are 90 degree, right? Now, since AB is parallel to DC, in a rectangle, AB will be parallel to DC. Yes or no? Yeah.
yes, sir.
So therefore,
yes,
angle DAB, DAC will be equal to angle ACD. Yes or no? This angle will be equal to this angle because they are alternate angles.
sir, you wrote BAC.
Sorry. Sorry, BAC, sorry. It should be BAC. So over here, this angle BAC is equals to angle ACB, right? By alternate angles, we know
Yes.
that, right? But we already knew that angle BAC is equals to DAC, right? This is what given, yes or no? Therefore, from this two, can I say angle ACD is equals to angle DAC? Angle ACD is equals to angle DAC. Yeah. Now, if I say in
Yes.
triangle ADC, since these two angles are equal, since these two angles are equal, therefore what? Therefore, triangle ADC is an isosceles triangle. Yes or no? This angle is equal to this angle, no? As per the statement.
Yes.
Therefore, triangle ADC is an isosceles triangle. Yeah. So if it is an isosceles triangle, then what we can say? AD is equals to DC, right? But AD will be equal to BC. Why? Because it's a rectangle. Opposite sides are equal. Yeah. But AD is equals to BC and AB is equals to DC. Since opposite sides of rectangle. Yeah, they are opposite sides of rectangle. Now, if these two are equal and AD is also equals to DC, this is equal to this is equal to this. So what we can say, all the sides are equal? Can I say?
Yes.
Yes, sir. So
Yeah.
it
Yes,
is a
sir.
square.
Therefore, AB equals BC equals CD equals AD, and therefore quadrilateral ABCD is a square. Clear? How we can prove if the diagonals are
Sir,
bisecting? Yes.
sir, I didn't understood that like how angle ACD is equal to angle DAC. So
See, we already knew that this angle is equal to this and this angle is equal to this. Why? Because AC is bisecting both the angles. Is this clear, Dhruv?
yes,
Yeah. After that, if this line is parallel to this line, then this angle will be equal to this angle, yes or no?
yes,
That
sir.
means all the angles are equal. Yeah.
Yes, sir.
Yeah. So if this angle is equal to this, that means this angle is also equal to this. So if this angle is equal to this, that means it's an isosceles triangle and both the sides are equal. And therefore it is a square.
Yes, sir.
Clear?
Understood, sir. Yes.
Okay. Anyone else have any doubt? You can ask. No doubt? You can also nod your face. No doubt. Like that. No doubt. Okay. These are the next question. Let's solve question number 9. Now what is given over here? In a parallelogram ABCD. ABCD is a parallelogram. That means this side is equal to this side and this side will be equal to this side. That's what we already know from the parallelogram. Right? The opposite sides will be equal and opposite sides will be parallel also. Yeah. This side will be parallel to this and this side will be parallel to this. Fine? Yeah. Now after this, 2 points P and Q are taken on the diagonals BD such that DP equals PQ. Okay, if DP equals BQ, we can say this side is equal to this side. Fine. Then you have to prove that triangle APD is congruent to triangle CQB and so on, whatever they have given. Okay, we'll try to prove them. Okay. Now, what you have to first, you have to prove that triangle APD, this triangle APD is similar to triangle CQB. These two triangles are congruent. That's what we have to prove. Okay. in triangle APD and triangle CQB. In these two, what do we know? AD is equals to BC. Yes or no? What will be the reason?
Opposite sides.
Parallelogram given.
Parallel.
Yeah, it will be opposite sides of a parallelogram. The reason will be opposite sides of parallelogram. Yeah, this is opposite sides of parallelogram. After that, this angle will be equal to this angle. Yes or no? Since AD is parallel to BC, then this angle
Yes,
is
sir.
equal to this. Why? What is the reason?
Sir, because it creates a
Alternate
transversal.
angle.
Transversal, and it is alternate angles.
Yes,
Alternate
sir.
angle.
Yeah. So what we can say, angle ADP is equal to angle CBQ. Why? Alternate angles. What would be the next thing which is equal? Yeah, anyone? Please tell me what is
So
the next thing.
BQ equal to DP
That's
given.
given. Yes, perfect. What do we know? That is PD is equals to BQ. Why? Because it was given already. So then what we can see that the two triangles, see this side, this side, this side and this side. So side, angle, side. The angle should come in between the two sides. Only then we can say it is SAS test. Yeah, otherwise it is not. The angle should come in between the two sides which are similar, which are equal. So therefore what we can say, therefore the two triangles are, therefore triangle APD is congruent to triangle CQB by SAS congruency test. Congruency test. Clear? Yeah, the two triangles are, so the first one is,
Yes.
so the first one is done. Next is AP is equals to CQ. How AP will be equal to CQ? Yeah, they will be equal. Why? Because they are corresponding parts of congruent triangles. Therefore, AP is equals to CQ by CPCT. Yeah. So the second part is also cleared. Next, triangle AQB. Triangle AQB is congruent to triangle CPD. See, you have to do it similarly. What all things you will do? Please tell me anyone verbally. What you will do to prove that the two triangles are congruent?
Sir, one will be opposite sides of a parallelogram AB equals CD.
Okay, and
BQ equals to DP.
what was that? There was a cooker city is going on, and you have kept yourself unmuted. Yeah, yeah. Please
Sir,
tell.
we can also say AQ equals PC because we proved it earlier.
Where did we prove?
So BQ equals to DP.
Yeah, BQ is equals to PD. That because that was given. Anything? What will be the next thing which is equal?
Angle ABQ equal to PD.
Yes, this angle is equal to this angle, and then we can prove that the two triangles are congruent. By which test?
SAS.
Yeah, that will be from
SAS
SAS.
test.
After that, how you prove that AQ equals CP?
CPC.
Corresponding parts of congruent one.
Yes,
CPCT.
yes. Now, how you prove that this is parallelogram?
Sir, both the opposite sides are equal. So it is.
Sir, it
Exactly.
is given.
Yeah, since no, it is not given. APCQ is not given. We are talking about
Oh,
this.
yes.
Yeah, APCQ. See, we have already proved that this line is equal to this in the first statement, and this line is equal to this over here. So if these two opposite sides are equal, then we can say that the quadrilateral formed is a parallelogram. Is that clear, everyone?
Yes, sir.
Yeah. How many of you have understood each and everything? Please raise your hands like this. Please raise your hands like
Sir,
this. Yeah.
sir, how it is a parallelogram? Because all the sides are equal. No?
Yeah. All the sides are not equal. What is the requirement to be a parallelogram? What is the requirement to be a
Opposite
Yeah,
opposite sides need to be equal.
yeah, that's what. See, in this condition, AP equals CQ, AP equals CQ, this side is equal to this side. Yeah, and in the next one, AQ equals CP, this side is equal to this side. So we have proved only the opposite sides are equal, no? So can we say that it is a parallelogram?
Yes, sir.
Yeah. So please raise your hands like this, or you can also put a raised hand. Yeah. The next question is this. Over here, what they have given, ABCD is a parallelogram. Okay. And AP and CQ are perpendicular from the vertices A and C on the diagonals BD. You have to show that APB is congruent to triangle CQD. Yeah. APB means this triangle is congruent to this triangle. You have to prove this. Yeah. So how we will prove this? It is given that quadrilateral ABCD is a parallelogram. So quadrilateral ABCD is a parallelogram. This is given, and therefore what we can
Sir, it
say.
also says perpendicular. So we can do angle by that.
Yeah, we will be doing it. We will go in sequence, no? So over here, ABCD is a parallelogram. So we can say that DC is parallel to AB. Yeah. So can I say CDB or CDQ? Fine, we'll keep it like this. Now let us prove that in triangle, whatever the two triangles is they have asked, triangle APB and triangle CQD. In triangle APB and CQD, what all things we know? That,
AB equal to this.
yeah, what all things we know, that is AB is equals to DC. What is the reason?
Opposite
Uh,
sides of
opposite sides
triangle.
of what? Parallelogram. Yeah, opposite sides of parallelogram. After that, angle CDQ, sorry, ABP will be equal to angle CDQ. What is the reason? Alternate angles.
Alternate angle.
And angle APB is equals to angle CQD. What is the reason?
90 degree.
Each 90. Yeah, each 90 degree. Both are 90 degree. So what all things we had? This angle, this side, and this angle, right? So angle side it is, and it's a right angle. So what we can say, RHS, right angle, hypotenuse, and side. No, it is not right angle hypotenuse. It is Aas test. Why? Because these two angles are equal and this side is equal, right? So it is Aas test of congruency. Therefore, triangle APB is congruent to triangle CQD by Aas test of congruency. Clear? Why it is Aas? Why it is
Yes,
not ASA? Anyone please tell me?
sir, because the line is not included between the two angles.
Yes, perfect. Very good.
So,
Yeah.
so how angle ABP is equal to angle CQQ by alternating figures angle?
See, we know that these two lines are parallel because it's a parallelogram. So then this angle will be equal to this angle, no? Yes or no?
Yes.
Yeah. Any other doubt anyone has? You can ask. Any one of you, if you have any doubt, you can ask. Yeah. No doubts? Fine then. So over here, the two triangles are congruent by Aas
Sir,
test of, yeah,
sir, but it should be CQD, right?
CQD. So what I have written? CQD
So you
only.
have written, no, so you
It's
have written
s- no, it is CDQ. CDQ it is. Oh, it's look like it's CDQ. Now it's clear?
Yes, sir.
Okay, fine. So this is done. No, there is one more requirement. You have to prove that AP equals CQ. How you'll prove?
CPCT.
By CPCT.
CPC.
Yeah. Now AP is equals to CQ by CPCT. Very easy. Yeah. Now we'll go to the next.
Yes.
Okay. Now what is given in the question? In triangle ABC and triangle DEF, these two triangles, AB is equals to DE, that means this side is equals to this side, and AB is parallel to DE, that means this side is parallel to this side, and BC is equals to EF, that means this side is equals to this side, and BC is parallel to EF, that means this side is parallel to this side. Okay. After that, vertices ABC are joined to vertices DEF, fine. Respectively, you have to show that quadrilateral ABED will be a parallelogram. Yeah, how we can say ABED is a parallelogram? Anyone? Wait, who can
Recognize.
tell? Wait, who can tell? Juhi, please wait. Nandini, can you please tell how we can say that ABED is a parallelogram?
So it is given that AB is equal to DE and
Hmm.
also AB is parallel to DE. So same pair of opposite sides are equal and parallel, so it is a parallel.
Yes, perfect. So what is the reason? The reason is if you have any quadrilateral, for any quadrilateral, if opposite sides are equal and they are parallel also, means if you have a two quadrilateral like, means you have a quadrilateral like this, okay, if you know that this side is equal to this side and this side is also parallel to this side, that means the quadrilateral is a parallelogram. Got it? So you should be knowing this was the theorem. Okay, so over here, since AB is equals to ED and AB is parallel to ED, so therefore what we can say, quadrilateral ABCD is a parallelogram. What is the reason? For any quadrilateral, if opposite sides are equal and opposite sides are parallel, if what we can say, the reason is if same pair of opposite sides are equal and parallel of a quadrilateral then it is a parallelogram. Fine. Now we'll continue. So what did we had? That these two are this quadrilateral ABCD is a ABED is a what? It's a parallelogram. After that, this is done. How quadrilateral BEFC is a parallelogram? Now they are asking, you have to prove that this quadrilateral will also be a parallelogram. How we can prove this as a parallelogram? Anyone? Not
So
anyone.
same.
No, wait. Aryan, can you tell?
So
Yeah. How we can say that BEFC is a parallelogram? Dhruv?
Sir, it is given in the question like BC and EF are equal and parallel.
Exactly. Again, the same thing. These two lines are equal and these two lines are parallel. That's why we can say that that the given BEFC is a parallelogram. Everyone, is that clear? Yeah, please raise your hands if
Sir,
yeah.
sir, is it compulsory to prove that other pair of opposite sides the side is equal?
No, it's not required. If you have it, one pair of sides of a quadrilateral is equal and parallel, that's it. You can say that it's a parallelogram. Yeah, that is
Okay,
sufficient to
sir.
say it as a parallelogram. Because it cannot be a non-parallelogram. It has to be a parallelogram only. Because if two sides are parallel and equal, it will be the parallelogram only. Next, You have to prove that AD is parallel to CF. Now, how we will prove AD is parallel to CF? Anyone over here? Not anyone. Uh, Manasvi, Ritika, Shadan, can you please tell how AD will be parallel to CF?
Sir, just like we proved quadrilateral BCEF, we can prove ACDF also, and we can say CPCT.
No, no, no. We cannot say ACFD as parallelogram. Why? Because over here AC is equal to DF, that is not given, no? And AC is parallel to DF, that is not given. Dhruv, can you please tell how AD and CF will be? We can say that these two lines are parallel. Yes, Aryan.
Sir, actually,
Yeah,
I also don't.
yeah. You don't know? Juhi, can you please tell?
Sir,
Yeah.
in quadrilateral ABED, we can say that BE is equal to AD
Hmm.
by CPCT.
By
And in
CPCT.
quadrilateral,
By CPCT, how? Did we prove
no,
any two
sorry,
triangles are congruent?
opposite sides.
Huh.
Opposite sides.
Yeah, these two sides are equal. Fine. And
And in quadrilateral BCEF, BE equal to CF,
so,
opposite sides. So we can say that AD is also equal to CF.
yeah, that's right. And similarly, see, we know that in this quadrilateral, if I say about this quadrilateral, over here AD is parallel to BE, and in this quadrilateral, sorry, in this quadrilateral, I know that BE is parallel to CF. Yeah. So if this is parallel to this and this is parallel to this, that means these two are also parallel. Clear? Yes or no?
Yes, sir.
Yeah. And after that, they have given y AD is equals to CF, the same condition. This is equal to this and this is equal to this. So these two are also equal. Yeah. So in that way, you can prove this. After that, quadrilateral ACFD is a
Sir,
parallelogram. Yeah.
sir, how AD equal to CF?
See, AD is equals to BE. Yeah. Also, BE is equal to CF.
Okay,
Yeah. If these two set
got
of air, therefore all of them, all the three are equal, that means this is equal to this. Clear? Yeah?
yes.
Okay. After that, quadrilateral ACFD is a parallelogram. ACFD is a parallelogram because of this condition. If opposite sides are parallel and equal, therefore the quadrilateral is a parallelogram. So this is also proved. How you will prove AC equals DF? Yes, Ritika, can you please tell how you can prove AC equals DF?
So, sir, ACFT is a parallelogram, so AC is parallel to DF. So
Exactly,
AC will fit.
DF. Yeah. That AC is parallel to DF, that is not required. You can directly say AC
Sir,
equals DF.
CPCT, no?
Not CPCT. It is not CPCT. Who said CPCT in parallelogram? CPCT, what is the full form of CPCT?
Okay, sir.
Corresponding parts of congruent triangle.
So did we prove any two triangles as congruent over here? No. So why CPCT will be there? We did not prove any two triangles as congruent. So we cannot say by CPCT every time. Okay. After that, you have to prove that triangle ABC is congruent to triangle DEF. That can also be done. See, we have already done that ACDF is also a parallelogram. So this AC will be equal to this. This AB is already given as equal to BE and this is equal to this. So all the sides are equal. So what we can see that the two triangles are congruent by which test?
SSS.
SSS test.
Exactly. Is this clear? The whole sum is clear?
Yes, sir.
Yes,
Yeah.
sir.
Okay. Now let's go to the next. Over here, what you have? ABCD is a trapezium in which AB is parallel to CD. Okay. And AD is equal to BC. That is, this is equal to this. You have to show that. Fine. These two sides are equal and AB is parallel to CD. That means this is parallel to this. Fine. Now you have to show that angle A equals angle B. How we can show? To do that, they have already given some hint over here. So the hint is like you have to do some construction before solving the sum. What is the construction? Draw CE parallel to AD and extend AB to meet at E. Clear? The construction is clear? This part you have to draw. Extra part. Right? This part won't be given in your if this question comes in the exam, this line and this line will not be given. They will only give you the trapezoid. Only the trapezium will be given. Okay? Now you have to prove that what angle A equals angle B. How we can prove? See, we know that this line is parallel to this. Since AB is parallel to DC and AD is drawn parallel to EC. Yeah. If two opposite pairs of a quadrilateral are equal, then it is what?
Parallelogram.
Parallelogram. Therefore, quadrilateral AB, what is that? Sorry, ADCE is a parallelogram. It's what? It's a parallelogram. Yeah. ABCE is a parallelogram. Now, if it is a parallelogram, what do we know in a parallelogram? Sum of co-interior angles are equal to 180 degree. That means this angle plus this angle will be equal to 180 degree. That we know. Yeah.
Yes.
Okay. Also, one more thing before that. We have to prove.
Sir, there is a property in which parallelogram angle A equals angle C.
Yeah, that is there. That is also there, but that is not required currently. This angle is equal to this. Yeah, I know that, but that is not required currently. Yeah, in this, since AB, AE is parallel to DC. So can I say angle EBC is equal to angle BCD? What is the criteria? What is the condition?
Sir, alternate angles.
Alternate angle.
Yeah, that is this angle is equal to this angle. Fine. These two angles are equal. After that, also we know that AB is equals to BC, DC, which is given over here. AD is equals to EC. What is the reason? Opposite side of parallelogram. Yeah. After that, it was given that AD is equals to BC. Yeah, this was given. So can I say, therefore, EC is equals to BC?
Yes.
Therefore,
Yes.
can I say EC is equals to BC? So if AC is equals to BC, therefore triangle BCE is an isosceles triangle. Therefore,
Yes.
triangle BCE is an isosceles triangle. Yeah, it's an isosceles triangle. If it's an isosceles triangle, angle EBC is equal to angle BEC. Let's keep this as 1. Yeah, let's keep this as 1. Now, again, angle BAE plus angle BEC.
Sir, what will be angle BAE?
How
Which part?
angle BA is possible?
Sorry, not BAE, BAD. Sorry, it is BAD, not BA. Angle D and BEC, the sum of both of them equals 180 degree? What is the reason?
So how? So they're opposite.
Sir,
This angle
Sir,
plus this
adjacent angles are
no,
supplementary.
co-interior angles. Co-interior angles are supplementary of a parallelogram. Co-interior angles of parallelogram are supplementary. Is this clear or you want reason of this? Yeah, co-interior angles
Okay.
of a parallelogram are supplementary. Yeah, and opposite angles of a parallelogram are equal. Yeah, so the sum of both of them equals 180. Also, we know that angle ABC plus angle EBC equals how much?
180.
What is the reason?
Linear pair.
Linear pair.
Yeah, linear pair. But EBC is equals to BEC? Yes or no? These two are equal.
Yes.
So if this is 2 and this is 3, so from 1, 2 and 3, what I can say? Angle BAD will be equal to ABC?
Yes.
yes, sir.
Yes.
Angle BAD will be equal to angle BAD is equal to angle ABC. These two angles are equal, and over here we can say hence proved. Is that clear completely to all of you?
Yes, sir.
Anyone has any doubt in this?
So can you explain this in short once again?
Yeah, I will explain in short. See, the short explanation is even more easy to remember, which I will tell you at the end. You can ask it at every sum if you want it. See, what all things we know. I have drawn this CE as parallel to this AD. Yeah, so this is a parallelogram, right? So if it's a parallelogram, so this angle plus this angle will be equal to 180. If I say this is A and this is B, this angle and this angle will be equal to 180 degree. Also, I know that AD is equals to BC, which was given. Yeah,
Yes.
and this angle is equal to this angle, alternate angles. Yeah, and
Yes.
what was there? How this equal to this? Yeah, sorry. Not this angle is not required. This side is equal to this side, and this side is also equal to this side because it's a parallelogram. So these two sides
Yes.
are equal. So that means these two angles are equal. That means this is also B. Yes or no?
Yes.
Over here, A plus B is 180. So this plus this is also 180. So this has to be A. Therefore, the two angles are equal. Clear? Yes, Juhi, do you still have any doubt?
So that end part. What
End part.
is?
Okay. See, we know that angle A plus angle B equals 180 degree. This angle plus this angle equals 180 degree. Why? Because
Yeah.
co-interior angles of a parallelogram are supplementary, right? This, if this is x, this angle plus this angle will be equal to 180 degree,
Yeah.
right? So this angle has to be what? This should be what? If this plus this is 180, this is already B, and this plus this is also 180. So this has to be what?
A.
Got it? So that's why it has to be A. Therefore, the two angles are equal. Clear? Everyone over here.
Yes.
How many of you can say that almost everything is clear to you? Please raise your hands. 3 more sub questions are there. Okay, let's complete them. So the first thing is clear. Yeah. After that, we have to prove angle C is equals to angle D. How we will prove this? See again, this plus this should be equal to 180, and this plus this should be equal to 180. That means this two has to be equal. So that means therefore this angle AD, what we can say, angle BAD plus angle ADC equals 180 degree. Angle ABC plus angle BCD equals 180 degree. But BAD equals ABC. Therefore, from 1, 2 and 3, what we can say, this angle is equal to this angle. Is this clear?
Can you write?
Yes, sir.
Okay, fine. I'll write. Now, over here, what you have, angle BAD is equal to angle ABC. Proved above, right? And also we know that angle BAD plus angle ADC equals 180 degree, and angle ABC plus angle BCD equals 180 degree. See, we already knew that BAD equals ABC, and these two are already equal by numbers, so this both has to be equal, no? So what we can say, this is 1, 2 and 3. Again, from 1, 2 and 3, what we can say, angle ADC is equals to angle BCD. Is that clear?
Yes.
Next, what you have, triangle ABC. Triangle ABC is congruent to triangle BAD. Fine, we can prove that also. Let's take this triangle first, quadrilateral first. Just a moment. These two things we need to prove still. Yeah, triangle ABC. So for that I will have to draw a diagonal. How these two triangles are congruent? So I can say in triangle ABC and triangle BAD, what all things you have? Angle ABC is equal to angle BAD. How?
It is proved.
Proved above. You can write
Proved above.
proved above. Yeah, this is proved. After that, AB is equals to AB. What is the reason?
Common side.
Common.
Common side.
Yes. These two are equal because they are common only. Now, which is the other angle, which is other angle or side which is equal?
Sir,
Sir,
AD
AD
equal
equal
to
to BC.
Yeah. Why? Because it was given. Over here, AD is equals to BC. Why? Because it was given. So what all things we have? If you take it in one triangle, AB and BC and the angle between them is equal. So it will be which test? Aryan, Nandini.
So by
If I
CPC.
take the next one's name does not mean that the previous one cannot answer. You can still answer. If your name was taken, you can answer.
Sir, SAS.
Yes, yes, perfect. Very good. Therefore, what we can say? Therefore, triangle ABC is congruent to triangle BAD by, sorry, BAD by SAS test of congruency.
Sir, so now we can prove the diagonals are equal by CPCT.
Yes, obvious. Diagonal AC and diagonal BD, no? Therefore, AC is equals to BD by CPCT. Clear the whole sum? Everyone,
Yes,
please
yes,
raise your
sir.
hands if it
Yes,
is clear. You
sir.
can also raise your own hand like this. No need to do all those clicking and all. If you feel that you can raise your hand, you can raise your hands like this also. The next is the first exercise has been completed. Now we are going to do the next exercise. But before doing that, you have some theorems which you should understand. The proofs of this is not there. The proof of this, the proper proof of this will be there in your class 10th. Okay. The line segment joining the midpoint of two sides of a triangle is parallel to the third side. That means if you have any two triangles like this, means any one triangle, not two triangle, means any triangle like this. Okay, and if you have the midpoint of this side and the midpoint of this side, okay, And if you join the midpoints of these two sides, what happens with this? This side will always be parallel to the third side. Got it? The line segment joining the
Yes.
midpoints of the two sides of the triangle is parallel to the third side. Fine?
So can you explain again?
See, if you have any triangle, any scalene triangle, it can be isosceles, equilateral, irregular triangle, any triangle it can be. But if you know the two midpoints of any two sides of a triangle, suppose if you know the midpoint of this, and if you know the midpoint of this over here, and if you join these two line, what will happen? This line will be parallel to the third side. Got it? Yeah?
Yes, sir.
Clear, no? So that's the theorem which you should know. Okay? One more theorem. Also, it is just the converse of this theorem. What does this theorem states? The line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. What does it mean? Again, see, I'll draw a triangle again. Suppose this is any triangle. Now the line drawn through the midpoint of one side of a triangle. So through the midpoint of one side, suppose if you know any one of the midpoint of this triangle, suppose if you know that this is the midpoint, and if you draw line parallel, if you draw line from this point parallel to this side, okay, parallel to this side, then what will happen? The line wherever it intersects the third side will be the midpoint of that third side. What they said? The line drawn through the midpoint of one side of a triangle to another side bisects the third side. Bisects means it divides the third side into two equal parts. It is the same thing only. It is just the converse of whatever we have learned above. Means if you
Yes,
draw,
sir, it's just the opposite.
yes, it is just the opposite. Means if you draw line to two, if you join two midpoints, it will be parallel. And over here they're saying if you draw parallel and one point is midpoint, the other point will also be a midpoint. Understood?
Yes, sir.
Yeah, the
Yes,
statements
sir.
are clear.
Yes.
How many of you have
Yes.
understood completely? Please raise your hands. So these were the two statements. And now let's go to the exercise.
Sir,
Yeah,
sir, you didn't teach us the midpoint theorem.
midpoint theorem.
Yes, sir.
Wait, the theorem proof is not there, no? Wait,
So in our school, it is proof is done.
in school it is done. Wait.
For 8.9, they have given. 8.10 also they have given, but they told that it is not likely to come for exam. 8.10. But 8.9 proof can come.
8.9 also the proof is not there. It's wait. Can prove this theorem using the following. They have given some clues over here. So such type of clues means this cannot be asked in. There is a proper theorem which can be asked, which is there in your class 10. Means what you do in this two is you draw these two lines and then you prove that the two triangles are congruent. Like this kind of lines we draw it. And then we prove that the two triangles are congruent and all, and then we do it. Okay? So that type is not there in your class 9th. Even in your textbook it is not there. They have written some statements. Okay, so the statement wise will not be asked in your exam. Okay, for the time you only have to do with the statements. In the class 10th you will be having with the proper proofs. Okay,
And sir, in our textbook, two examples are there. Can you solve that? Can you explain it?
examples means which two examples? What is the page number?
Example 7 and 8.
Okay, example 7 and 8. You want to understand that?
I
Did you?
have doubt in both of them.
Acha, you have doubt in both of them. Fine. Okay. What is given in triangle ABCD, D, E, F are respectively the midpoints of the side AB, BC and CA. Show that ABC is divided into 4 congruent triangles by joining DEF. Yeah. They are 4 congruent triangles you have to prove. Fine. See, we know that if we are, since all these points are midpoints, so all of them will be parallel to each other. Means this DF will be parallel to this will be parallel to this, and this will be parallel to this. Yeah.
Yeah.
Also, one more thing you have in the theorem, that if you draw lines which is parallel to this side, means if this is A, B, C, D, and E, you have what you have, DE will be half of BC. Yeah. If you join the two lines which are at the midpoint, so what you get is this side will be the half of the third side, and this side will also be parallel to the third side. Okay,
Yes.
fine. Now over here, what you have? Now in triangle ABC, what you have? DF is parallel to BC because they all are drawn as the midpoint. Yeah,
Yes.
DF is parallel to BC, and DF will also be half of BC. Yeah.
Yes.
So the two triangle means all the triangles are congruent. They are saying no. That show that triangle ABC is divided into 4
So that we
congruent.
have to prove.
Yeah, yeah. They are asking to prove that tri is divided into 4 congruent triangles by DEF. Okay, DF is equals to half of BC.
Sir, in this they have means the that DEF triangle is there. No, that they have proved congruent with all the other three.
Yeah, all the triangles are congruent to each other. Means
That
even
how.
yeah, that's what
Yeah.
we are going to prove it. This triangle and this triangle are congruent. This triangle and this triangle is congruent, and this triangle is also congruent to all the three triangles. Yeah. Yeah, the statement, the way which they have used is a different. See, we know that DF is parallel to BE. Can I say that? DF is parallel to BE. Also,
So it
EF.
is parallel to BC.
Yeah, you can say BE also, no? It is the
Okay.
same line. Also, EF is parallel to BD. Yeah,
Yeah.
again. Now, if these two are parallel, then can I say that therefore quadrilateral BDFE is a parallelogram? Is a
Yes.
parallelogram. Now, in a parallelogram, if you draw a diagonal, the two triangles will be congruent only. Why? So, it's a parallelogram. Now, DE is a diagonal. DE is a diagonal. If I take this diagram over here, DE is a diagonal. Now, in triangle DBE and triangle DBE EFD. Okay, in these two triangles, what all things you have? This angle will be equal to this angle. Why? Because it's opposite sides of a parallelogram. Angle DBE is equal to angle DFE, opposite sides of parallelogram. Yeah.
ED equal to ED.
Yeah. Also, DF is equals to BE. Actually, the angle is also not required. You can prove it by SSS test only. This is also angle is also equal, but we can say DF is equals to BE, opposite sides of a parallelogram. Also,
Yes.
BD is equals to EF, opposite sides of a parallelogram, and DE is equals to DE. Why? Common.
Common.
Therefore, the two triangles are congruent by SSS test of congruency.
Yes.
Yeah. If these two triangles are congruent, similarly, I can do that ADEF is a parallelogram. Yes or no? Because this line is parallel to this, and this line is parallel to this. Therefore, this will be a parallelogram. Again, if you draw a diagonal, these two triangles will be congruent.
Yes.
Similarly, if you dot this, if you take this as a parallelogram, yeah, if you take this as the diagonal, these two triangles will be congruent. That means this middle triangle is congruent to all the triangles. That means all the triangles which are formed are congruent.
Okay.
Understood?
Yes.
Okay. Over here, L, M, N are three parallel lines intersected by the transversal P and Q. Okay. Such that L, M, N cuts off equal intercepts AB, BC on AB, BC on P. Okay, cuts equal intercepts. AB and BC on P show that LMN cuts off equal intercepts DE, EF on Q also. That what is the means the statement? They are cutting equal intercepts means what? AB is equals to BC.
AB equal to BC.
Yeah, that's what is given. So now if you take this triangle, if you take this triangle, what you have? No, that triangle is not required. Um, what do you have? We have to prove what? LM means this are also cut at equal intercepts. Okay. Yeah, we can say that these are the midpoints, no? Yeah, so this will be parallel. So what they have used, similarity or what they have used? Okay. So what you have over here, see it was given that LMN are three parallel lines and this equal intercepts, right? So equal intercepts means AB is equals to BC. Yeah. So if AB equals BC, that means what? B is the midpoint of AC. Yeah.
Yeah.
And also this line is parallel to this line. So if this line is parallel to this line, so this has to be a midpoint by the second theorem which we know. Yes or no?
So can you tell again?
See, this B is the midpoint of AC
Yeah.
and it is given that this line is parallel to this line. Yeah. So if
Yes.
this line is parallel to this line, so this line, if I draw any line parallel to the third side, this line cuts the third side at the bisects the third side.
Okay.
Yeah.
Okay.
So that means G is the midpoint of AF.
Yes.
That is proved. Again, this line is again parallel to this AD, this line L. So if I draw a line
Yeah.
parallel to this L, so this will also be a midpoint of DF.
Yes.
So that's it. DE is equals to EF.
Okay.
Got it?
Yes, sir.
Yeah.
Yeah.
Clear, no? Okay. Fine. After this, yeah, we'll start with the next exercise which we have now. Okay. Now ABCD is a quadrilateral in which PQRS are midpoints. Okay. Now see over here what they have given. Will yeah.
Sir, we haven't done midpoint theorem.
Midpoint theorem. Fine, we'll do it properly in the next class. We don't have much time also. We'll explain you the midpoint theorem. Okay, in the next class we will do. Okay, I will write it down over here. Midpoint theorem. We need to do, right? So just I should be we'll do it. Okay? We'll do it in the next class. But let me complete this. Now over here, ABCD is a quadrilateral in which PQRS are the midpoints of the sides AB, BC, CD and DA. Okay? AC is the diagonal show that SR is parallel to PQ. SR is parallel to AC. This is what you need to show. Right? See, all these points are midpoints of the quadrilateral. Yeah. So SR, whichever you draw, this will be parallel to AC only. Why?
Midpoint theorem.
Midpoint theorem. Yeah. So
Midpoint theorem.
if any line drawn means line drawn through the midpoints of the two sides will be parallel to the third side. So that means SR will be parallel to AC. That's it. Midpoint theorem. And SR will be equal to half of AC. That is also the midpoint theorem. Yeah. Both of
Yes.
them are the midpoint theorem. And how you can say PQ is equals to SR? PQ is equals to SR. See this since SR is equals to half of AC and PQ will also be equal to half of AC.
Yeah.
Yeah, by midpoint theorem, since PQ is also parallel to AC. So since both of them are equal to half AC, we can say SR equals PQ. Yeah, so the second one
Yes.
is proved. And how you can say PQRS is a parallelogram? We can similarly do that RQ is equals to SP, the same way as we have done SR is equals to PQ, right? Similarly, we can prove that, or that is also not yeah, that is not required also. We know that SR is equals to PQ and SR is parallel to PQ. So the
Yeah.
quadrilateral will be a parallelogram since
Yes, sir.
single pair of opposite sides are equal and parallel. Therefore, the quadrilateral is a parallelogram. Okay. Further to this, the midpoint formula, the midpoint theorem, if you want to do, I'll do it. And the further exercise also we'll be doing in the next class. Okay. Chalo then. Bye bye everyone.
Yes,
Have a
sir.
good day.
Bye, sir. Thank
Yeah.
you, sir.
Yeah.
Bye, sir.